Okay, so for me, I started picking up. I feel pretty good about NumPy, or what is it, Matplotlib and NumPy. NumPy is the main base on what it is. I can get to the interactive window, no problem now. But he's giving me some stuff. I mean, I like some of his other stuff, Rookie, but this got pretty heavy in a hurry. I do appreciate the Lambda function because that brings me back to sheets here with a Lambda function for a timestamp. And I can make that array work. I can make that make sense to why it's an array because it's going to bring down the whole system like that. And at least that's practical for me in terms of what the first order is, because for me, I look at something like this, and I'm pretty decent with math, but in a training aspect, I can't express how critical it is. That's the first thing I'm going to go to is this origin source vector 0, 0, and I'm going to go about moving that point around because essentially I'm taking this math and we want to be able to express it with a written form like this that actually applies to a practical form, because this has got to be some level of chemistry, hydrogen, a type of a formation of a star, or whether it went super massive black hole and a great gas collapse. That is pretty heavy, but it's also right at the first order, right? It is right there. You got to get past it, and that's something you'll hear in the satire pushing through this about what that is. Because for me, again, I can't really be sure that this is, I mean, there's a 4 there, there's a 2 here. Obviously, I got to get it past the 1 and the 2 because it'll just fall to the singularity. So you have to get out there and you have to express that in that point. Then you can flip the axes around, do metrics rotation and things like that to really show you that there's like an X and a Y variable in both of those things. And again, for me, the brain wants it to be just all X's and Y's, right? As soon as you start adding numbers to it, it gets a lot more complicated, like by scales of magnitude, because these are pretty heavy calculations when you think about the RAM and GPU that's putting into it. All that ones and zeros just goes right down to a temperature on your CPU or your GPU, right? And that's the epsilon, or excuse me, the omega. You approximate that so that way this number is natural to, now that you found out what 1 is, it drops it back down to 0. It brings it back down. Even though it exists in a state, there will be some level of decay to it, change to it, frame drag about it, because we have to take the world out of this equation realistically. But that applies it in a way that it can occupy a space in negative 273 Kelvin. As long as this is roughly tracking the orbital or the stock price of whatever. And again, you'll be doing a lot of fancy stuff just because this outputs it to you. You'll be looking at it more. You'll be doing stuff with it. Become more intuitive about it inside of the situation. But I just wanted to drop that note in here. If you got to do stuff like this, make sure that you're explaining it to a guy like me from the first order. I'm going to bring it back to the vector. We're going to start to build it out because that's going to be the like matplotlib. You're building your plot, then you're you're gridding out the points. I forget exactly what it is. And that's a pretty rudimentary style, and you want to always stay into that and then build off of that for your grid types, to build off of that for a type of mathematical principle. If we were in integrals or function of the domain, which we will always be in function of domain as long as you're going about changing x. Here it's a storaging value. Here it integrates the ability to actually say there are ways to put a x squared function in this ability and then have the computer understand it. And I'm quite a ways from that, but I just, this stuff is actually pretty easy when you think about it that way. And that was my note. So